In this video, we're going to overview radical equations, and really the goal here is just to be able to solve radical equations, including those in context. And then there's kind of three different things we need to be able to do. We need to be able to solve radical equations involving radical expressions, and then remember, every radical is really a rational exponent, so we're going to see those as well, rational exponents in equations, and then context. Okay, and our contexts here are going to be pretty straightforward, I'll say, because it's just solve for a variable or plug some numbers in and get this other number out. And so when we're talking about radical equations, what we're using that to indicate is that we have an equation, okay, again, equal sign present, two sides are there, and at least one of the terms in this equation is something that has a radical in it, okay? And then you'll remember index and radicand and all that good stuff, okay? And so but this is just an overview of what we have done so far. We've talked about PEMDAS, we've talked about properties of equality, factoring, right? And then we just finished our study with quadratic equations, right? We saw how to factor, perfect square, identities, and then quadratic formula. And then we're going to continue to use these, and you'll notice that, okay, we went from 2.3 to 2.6. That is intentional because these radical equations connect nicely to the quadratics. We will return to 2.5, but I do want to give a little hand wave to 2.4, which we are skipping in the course. Okay, and so here, these are some of the equations that you might have seen in that section, and I just want you to pause the video and see if you can identify some ways to attack these problems. Okay, well, the first one, you might notice that there's the x squared plus 2x in each of them. So you could, FOIL it all out, and you're going to end up with something that's like a degree 4 polynomial, and that's going to be really challenging to solve. Otherwise, what I would say is this is the same in each. Rather than working with that complicated thing, let's define a variable, y is equal to x squared plus 2x. Okay, and then with this, I can just do a substitution, and I can say, well, this thing in parentheses, that's really just y, and then this is squared minus 7y, and then minus 8. And with this, this is equal to 0. I can factor this much more easily, y minus 8 and y plus 1. And then I get y is equal to 8 and y is equal to minus 1. But then really remember that I have to go back, and y is really this x squared plus 2x. So then x squared plus 2x is equal to 8, and x squared plus 2x is equal to negative 1. And then, of course, move this the other side is equal to 0. Move this the other side is equal to 0, factor this all, and here you get x is equal to 1, minus 1 rather, and here, if I'm doing the math correctly in my head, x is equal to minus 4 and positive 2. Okay, so then you get the answers that way. For the second one, you'll notice that there's an x squared in common with everything as well as a 3, so I might factor that out. 3x squared, and then I'm left with x squared plus 6x minus 7 is equal to 0. And now this one is just meant to rely on your familiarity with GCD. And then certainly you can factor 3x squared, x plus 7, x minus 1 is equal to 0, and then so we get x is equal to 0, x is equal to minus 7, and x is equal to 1. Okay, and then for this last one, you could take the fourth root of each side if you wanted to. I would actually recommend moving the 9 over and factoring this thing. This ends up factoring. This is a difference of squares where you have x squared minus 3 and x squared plus 3 is equal to 0. This second one does not factor, but this can be viewed as another difference of squares. It's a little awkward, but we can do it. X minus square root of 3, x plus square root of 3, and then x squared plus 3 is equal to 0. Okay, you had set them each equal to 0. From the first two, you get x is equal to square root of 3 and negative square root of 3. And this last one, the x squared plus 3, that actually gives you an imaginary number, so we don't get any real solutions from that, but we still can talk about these as the two real solutions. Okay, so this is just, again, a brief overview of what we've done in the course so far, as well as kind of introing what we're going to be talking about with radical equations. And then also just a nice little hand wave to the skills that we can use in 2.4.